Alright, having built up a little bit in our ability to check for homogeneity and additivity, let's test this function right here for homogeneity. I'm going to say if this function is algebraically defined this way, then for an arbitrary scalar c, f of c times xy, well, look, xy is an arbitrary vector, is f of cx cy, using the rules for scalar multiplication of a 2 vector. Now, I simply replace x with c times x and y with c times y to get this, and then, hey, I can factor a c out of every single term, and indeed out of the entire 2 vector, and then I can say that this is c times f of xy. See how I don't need that that line where I say and c times f of xy is equal to, and then leave it to the reader to see that the 2 expressions I get are the same. No, I've shown that this comma. So f is homogeneous. And you may be wondering what the picture looks like for this, so give me a second to draw it. I'll be right back. Get out of your hand. And there it is. Okay, in black, I hope you can tell the color difference. I feel like my camera's a little weird today. Anyway, in black, I have the vector x, the vector 1, 2. In blue, I have the vector c times x, 3, 6. 3 times x, 3, 6. And forgive me for accidentally writing 1/2 again. Here, maybe I'll try to fix it this time. There. That is 1, 2. 1 on the first component, 2 on the second component. That is probably the ugliest one I've ever drawn, but forgive it. Okay, so I have x and c times x drawn over here for these particular numbers. And then over here, I have f of x. That is what f assigns to the vector 1, 2. F assigns to the vector 1, 2, 7, 4. So 7, 4, there it is. The thing that f turns x into, f of x. And f turns c of x, and c of x is, c times x is 3, 6. F turns that into 21, 12. There it is. And the last thing that I need is c times f of x, and that is supposed to be 3 times this vector, which would be the same direction, but 3 times longer. This is c times f of x, 21, 12. Exactly the same vector as f times c of x. So that's what homogeneity looks like.